Good day to all. Today we are going to discuss about carbohydrate. Carbohydrates are very important organic compounds widely distributed in nature. These include sugars such as glucose, fructose and sucrose, as well as non-sugars such as starch and cellulose. Sugars are crystalline substance which has sweet taste and are soluble in water, while non-sugars are non-crystalline substance which are not sweet and are insoluble or less soluble in water. Carbohydrates are polyhydroxyaldehyde or ketones. They are primarily produced by plants and form a very large group of naturally occurring organic substances. Some common examples are canned sugar, glucose, starch. They have general formula that make them appear to be hydrates of carbon CxH2OY. Classification. Carbohydrates are classified into two main classes, sugars and polysaccharides. Sugars are sweet crystalline substances that are soluble in water. They are further classified on the basis of their behavior on hydrolysis. There are two types of sugars, one monosaccharides, two oligosaccharides. Monosaccharides. These are the simplest carbohydrate which cannot be hydrolyzed further into smaller unit. They contain 4, 5 or 6 carbon atom and are known as tetrosose, pentose and hexosose respectively, depending upon whether they contain an aldehyde or keto group. They may be called aldoses or ketoses. For example, a 5 carbon monosaccharide having aldehyde group is called aldopentose, and a 6 carbon monosaccharide containing a keto group is called ketohexoses. The example for monosaccharide is glucose, fructose, galactose. Oligosaccharides. These are the carbohydrate which can be hydrolyzed into a defined number of monosaccharide molecules. Depending upon the number of monosaccharide that are obtained from them on hydrolysis, they may be called di, tri or tetrasaccharides. For example, disaccharides. These give 2 molecules of monosaccharide on hydrolysis. Sucrose on hydrolysis gives 1 molecule each of glucose and fructose, whereas maltose gives 2 molecules of glucose. Example: maltose, sucrose, lactose. Polysaccharides. These carbohydrates give a large number of monosaccharide units on hydrolysis. These monosaccharide units are joined together by oxide bridges. These linkages are called glycosidic linkages. The common and widely distributed polysaccharide correspond to the general formula C6H10O5N. Polysaccharide are not sweet in taste, so they are called non-sugars. Some common examples are starch, glycogen, cellulose, fibers. Preparation of glucose. From sucrose, glucose can be easily prepared in the laboratory by the hydrolysis of an alcoholic solution of canned sugar with dilute HCl and H2SO4 in alcoholic solution. Glucose and fructose are obtained in equal manner from starch. Commercially, pure glucose is manufactured by the hydrolysis of starch with dilute mineral acid. Starch involves hydrolysis to give glucose. Chemical properties of glucose. Oxidation. Glucose get oxidized in the presence of bromine water to form gluconic acid. A strong oxidizing agent like nitric acid oxidizes both the terminal groups alcohol and aldehyde groups, and to form saccharic acid and glucuric acid is obtained. Reduction. Glucose is reduced to sorbitol or glucitol on treatment with sodium amalgam and water. On reduction with concentration Hi and red phosphorus at 373 Kelvin, glucose gives a mixture of N-hexane and 2-iodohexane. Reaction with hydrogen cyanide. With hydrogen cyanide, glucose gives cyanohydrate, and with hydroxylamine, it gives an oxide, indicating the presence of carbonate group in glucose. Reaction with acetic anhydride or acetyl chloride. When treated with acetic anhydride, glucose gives the pentaacetate. It's showing the presence of 5 hydroxyl groups. Since glucose is not easily dehydrated, each hydroxyl group must be attached to a different carbon atom. Interconversion, glucose and fructose, or conversion of aldoses to ketosis. The first step, the aldose is converted into ozone. The ozone is then converted into ozone by treating it with benzaldehyde. Ozone on reduction with mild reducing agent give ketosis or fructose. In this reduction, the more reactive aldehyde group of the ozone is reduced, not the less reactive keto group. In this reaction, there is no configurational change on the chiral carbons. Interconversion of fructose and glucose, or conversion of ketosis to aldoses. In this conversion, the first step is the keto group of the ketose is reduced to hydroxy group, resulting in the formation of epimeric aldetols. Oxidation of aldetols with nitric acid gives 2-aldonic acid. Under the acidic condition of oxidation, aldonic acid cyclizes to give lactones. And finally, sodium amalgam reduce lactone to hemiacetols. In effect, the carboxylic group of the aldonic acid is reduced to an aldehyde. Thank you.